Hi, so today we are looking at exponent rules. So you have learned these in the past, and I also linked to you sort of a cheat sheet of what all the rules are and how they apply. But just to recap real quick, because I'm sure it's been a while, the first rule that we're going to talk about is the product rule. So what that one says is that if I have something like x squared times x to the third, what does that actually equal if I kind of multiply that out? And one way I can look at this, think about what x squared really is. Isn't that just x times x, right? So x to the third, if I just do the same thing, that would be x times x times x. So now you see that I have 1, 2, 3, 4, 5 of them. So that means I'm going to get x to the fifth if I multiply x squared times x to the third. So what do you think the rule is? What do you do with a 2 and a 3 to get to a 5? Yes, you add them. So if you have, as long as you're multiplying two numbers with the same base, so remember this number down here is called the base. So in my example, oh yeah, it was X still there. Okay, so I have my bases, they're both X's, and then I have my exponents, in this case are A and B. So to multiply those two numbers together, you're just going to add the exponents. Okay, so that's our rule, that's product. So let's try a couple problems that demonstrate this. Okay, so if I'm looking at number one, me personally, I always handle the numbers first. Remember, this is all multiplication. So I'm going to multiply 3 and 4 together. It gets me 12. And then you're going to work your way through alphabetically. So I'm going to look at the x's. I have x squared times x to the third. So we just did that example. It's going to get me x to the fifth. And then I'm going to look at the y's. Y to the third and another y to the third together is going to get me a y to the sixth. Okay, let's take a quick look at number 3. You'll notice this in here. Do you remember what that is? X to the 0 power. What is that? Hopefully you're remembering, oh yeah, anything to the 0 power is just 1. Okay, and well, I guess I'll talk about y right now real quick. You have a division rule that we're going to look at in a little bit. If you had x to the fourth over x to the third, let's say, what ends up happening is that all of these are going to cancel out. You have x to the fourth on top, x to the third on the bottom, right? All of these are going to cancel out. So what's left is just x to the first power. So your rule says that if you're dividing two numbers with the same base, you can just subtract their exponents, right? So if I do 4 minus 3, I'm going to get to that 1. And I get to jump over writing all that out in the middle. Okay, so that's my rule. So if I had this, if I had x to the fourth over x to the fourth, well, following that same logic, I'd have x to the 0 power, wouldn't I? But go back to this. What is, if you have a fraction with the exact same thing in the numerator and denominator, isn't it just 1? Like, isn't 3 over 3 just 1? Or 10 over 10 is just 1? So x to the fourth over x to the fourth is just 1. So that means no matter what x is, but there is one caveat, there is someone that I cannot put into that fraction, and it's 0 to the 0 power. So 0 to the 0 power is not 1. This is the only one that's undefined because I can't have 0 in the denominator. Okay, but every other number, if you raise it to the 0 power, it automatically turns into a 1. Okay, so when I'm looking at number 3 and I see this x to the 0, in my head, I'm literally just doing that because it just turns into a times 1. So 3y times 1 is just 3y, so I don't even need it. One common mistake, though, I will tell you, is that kids will do this. They'll see this, they'll come in, and they see 3, oh, geez. There we go. They'll see this, 3yx to the 0, and they'll think that the whole thing cancels out. That is not true. The only thing being raised to the 0 power is the x. If I wanted to raise the 3, the y, and the x, all of them to the 0 power, I'd have to put them in parentheses. That would be 1, okay? So this, yes, absolutely would cancel out and that whole thing would just be 1. But that is not what I have in the original problem here. So let's do this one out. So the x goes away, sure, but the rest of it does not. So now I'm going to multiply the numbers. 2 times 3 is 6. X, I only have the 1x, so it's just going to stay. And then another thing to be cautious of, this y right here, it does have an exponent, right? It's a 1. So don't forget that there's a 1 there. So when I put the y to the 4th with the y to the 1st together, that's going to get me a y to the 5th. Okay, and there's my answer right there. All right, the next rule that we're going to talk about is the power property. So that's kind of like these 5 to 7. So what this rule says real quick is if I take something like, let's just stick with the x squared. If I take x squared and then I cube it, so now I'm raising a power to another power. What happens here? Well, let's kind of do it out. If I do x squared and I cube it, wouldn't that be this, x squared times x squared times x squared, right? And then now I can use my product property. 2 plus 2 plus 2 gets me x to the 6th. So my rule, if I raise a power to another power, I'm actually going to multiply those values together to get my new exponent. So if I had, if I did x to the a and then I raised it to the b power, that's going to get me x to the a b, multiplying those exponents together. Okay, so raise the power to a power. So if we look at number 5, I'm raising a whole bunch of things to the 4th power. I'm raising everything in that parenthesis to the 4th power. So I'm going to give everybody in here that exponent of 4. So this now becomes 4 to the 4th, x to the 4th, and then y to the, what do you think that y is going to be? Hopefully you're saying to the 12th, because I'm raising a power to another power. So I'm going to multiply those exponents. You do with the x, right? Remember there's a 1 there. So I did 1 times 4, and that's how I got that 4. 4 has an exponent of 1 on it too. So I get 4 to the 4th. Okay. 4 to the 4th is just, what is that, 256? Should you do those out? Okay, so, I mean, if it's a ridiculously large number, absolutely not. Like if it was 4 to the 5th, don't bother. Just leave it, okay? You know, if the number's not so crazy, yes, you should absolutely. If it's under 100, for sure. Like, don't leave 8 squared, right? You would just write it as 64. But if it's, you know, 8 to the 5th, I would not want you to do that out. Why waste your time? Okay, so 7, let's see, same thing. I'm going to give everybody that exponent. So that's going to be 4 to the 4th, m to the 12th. And then we just said 4 to the 4th was 256. Okay, so there is your power property. Oops, geez Louise. There we go. Okay, let's take a look down at the bottom. I already mentioned to you the division ones. What your rule is, you're going to subtract the exponents if you have the same base. If you look at number 9, this is sort of a bad example to start with because that's an A and that's a B. They're not the same base. There's literally nothing to do with number 9. Okay, there's nothing to do. That is simplified. Can't go any further. However, let's look at number 11. Okay, so again, I always start with the numbers. So I have 4 over 3. I cannot reduce that, so it's going to stay 4 over 3. If it had been 4 over 8 or 4 over 12 or 6 over 8, anything that could be reduced, I would reduce it. Okay, but in this case, 4/3 does not reduce, so it's just going to stay. I also notice that I have this y to the 0, so that's pretty much just gone. And then as far as, I actually don't do the subtraction. I don't know, in my brain, I'm not doing the 3 minus 2. What I'm saying in my head is I'm saying, okay, if I have 3 x's on the top and 2 of them on the bottom, when I cancel them all out, what's going to be left? I'm going to be left with x to the 1st in the numerator. And the reason why I don't like to say, oh, just do 3 minus 2, you get 1, is because what happens when you have x to the 2 over x to the 3? Okay, 2 minus 3 is -1. But if you look at the directions here, it says your answer should contain only positive exponents. So what are you going to do with this? We're going to talk a lot more about negative exponents tomorrow, but that's what kind of a little, I don't bother with it this way. I just ask myself, okay, if I had 2 x's on top and 3 x's on the bottom, if I cancel them out, what would be left? I'd have 1x on the bottom. Okay, so I think that's a little bit easier to sort of think about how to do the division stuff. Okay, yes, the rule applies. I am subtracting, and we're going to talk, this is x to the -1, but we're going to go into that a little bit more tomorrow. Okay, so any hoosers, where am I? Did I finish 11? Yes, I did. So there's my answer to 11. It's just the 4x over 3. All right, now 13. Whew, this looks very intimidating, right? It's like, oh my gosh, are you kidding? I'm supposed to do this? It's really not that bad if you just go piece by piece. And another kind of cool thing about exponents is that it doesn't matter in what order you apply the rules. So you can do the power, like you could start off if you wanted. You could start by giving every single thing in here that exponent of 4. If you wanted, I would not recommend it, but you could, right? You could do that one first. You could start off by, oops. You could start by dividing anything that matches, right? Start simplifying those things. I wouldn't do that either. Here's what I would recommend you do. If I have a set of parentheses, which I do, I'm going to simplify what's inside those parentheses first. Okay? So I'm not even going to look at that to the 4th power yet. I'm going to do that at the very end. The next thing I'm going to do is I'm going to look at my numerator. I'm just going to start with the numerator. Is there anything to simplify in just the numerator if I ignore everything else? No. So that's for now is just going to stay. So I'm going to leave the to the 4th power, and I'm just going to leave the x squared y to the 3rd. In the denominator, I'm going to ask myself the same question, but I'm just going to look at the denominator. So let me switch colors here real quick. I'm just going to look down here, and I'm going to pretend like that's its own little mini problem. And I'm going to say to myself, okay, can I, does any of that simplify? Absolutely. So 2, and then I can put the x's. X to the 4th times x squared would give me x to the 6th, hopefully you're saying. And then I do the same thing with the y's. Y to the 4th times y squared gets me y to the 6th. Okay, so now the numerator is simplified, the denominator is simplified. Now I'm going to look at the whole fraction. So now I'm going to look inside, and I'm going to see if anything can simplify in the numerator and denominator. So I start off with the whole numbers. So there's nothing to simplify with the, let me just write this. I'm going to keep my 4, and let me switch colors again. I have, remember there's really a 1 here that we never write. So I have a 1/2 as my fraction. Well, I don't know why I wrote that one. I don't really need that. I'm just going to put the 2 in the bottom. You can write the 1 in the top. Who cares? You don't need it. So my numbers, nothing reduces. Now let's look at the x's. If you have 2 x's on the top and 6 x's on the bottom, and you were to cancel them all out, what would you be left with? Hopefully you're saying I would have x to the 4th on the bottom, right? Real quick, if you have 2 on top and then 6 on the bottom, 1, 2, 3, 4, 5, 6. So this is kind of what I want you to visualize. And then you're going to cancel out what you can. Look what's left, x to the 4th on the bottom. Okay, and then I'm going to look at the y's, and I'm going to kind of do the same thing. I have 3 y's on top, 6 y's on the bottom. If I cancel them all out, won't I be left with y to the 3rd on the bottom? Now, there's nothing left in my numerator. Does that mean I just ignore it and I don't have a numerator at all? No, there's always a 1. I mean, there is something there. It all just simplified to be a 1. Okay, so now I'm almost done. Now there is absolutely nothing left to simplify inside my parenthesis. Now all I have to do is give everybody the exponent of 4. And everybody gets it, numerator, denominator, everybody. So literally, I'm going to do 1 to the 4th, I'm going to do 2 to the 4th, I'm going to do x to the 4th, then raise it to the 4th, and I'm going to do x to the 3rd and raise it to the 4th. So 1 to the 4th is just 1, 2 to the 4th is 16, x to the 4th to the 4th, that gets you x to the 16th, and y to the 3rd to the 4th gets you y to the 12th. Okay, so hopefully that worked out. Let's try another one. Okay, 15. So again, I'm going to work through it in the order that makes sense to me. So I'm going to leave this raising to the 3rd part for later. I'm going to just look at my numerator. There's nothing to do in my numerator. Well, there kind of is. I'm going to write it as x squared y because I hate when they put it out of alphabetical order. But I mean, there's nothing for me to simplify there. And then in my denominator, I have a 2 that's not going to multiply with anything else. And then x's. I have x to the 1st times x to the 3rd, so that gets me x to the 4th. And then y to the 4th just stays. Okay, so step 1 is done. My numerator and denominator are simplified. Now I'm going to see if I can simplify the entire fraction. So again, I start off with my numbers. It's just going to be 1/2 again. So I'll just leave that 2 in the denominator. And then let's look at the x's. I have x to the 2nd on top and x to the 4th on the bottom. So if I cancel them out, what's left? X squared on the bottom. Okay, then let's do the same thing with the y's. I have y to the 1st on top, y to the 4th on the bottom. So if I have 1 on top, 4 on the bottom, cancel them out, you're left with y to the 3rd on the bottom. What's in the numerator? Always a 1. You can't leave your numerator blank, and it's never a 0, right? Those didn't go away to 0. It just reduces to be a 1. And now don't forget, I still have to cube this whole thing because I haven't done that part yet. So everything on the inside is done. The last thing I have to do now is raise everybody to that 3rd power. So 1 to the 3rd is just 1. 2 to the 3rd is 8. X squared raised to the 3rd power now gets me x to the 6th. And y to the 3rd to the 3rd, y to the 9th. And there's my final answer. Okay, so I hope you remember these. Give the evens a try, and we'll talk about negatives tomorrow.